This is day number 2 on Chapter 8, Section 3, Multiplying Binomials. And we are going to multiply some binomials in this first problem here. And so it says the radius of a tennis ball can is 2x plus 1 centimeters. So tennis ball can is cylindrical in shape, so it's going to end up looking something like this. And it's going to come down, and we've got a base on it as well. So we basically have two circles. A circle on top and a circle on the bottom of this. And so we have a radius, it says. The radius is 2x plus 1, and they give it some units here, centimeters. And so it says the height of the tennis ball can is 6 times the radius. So 6 times by 2x plus 1. And so that's the information given to us, and this is in centimeters as well. And so they want to know what is the surface area of the cylinder. And so the cylinder right here. So we talked about this a little bit yesterday, where a cylinder is basically two circles, the base and the two bases, the top and the bottom of the circle, and we have a rectangle. That's what the skin of this cylinder is, that keeps the bases from falling in on each other. And we find out that the height is the distance between the two bases, between the two circles, but this is the circumference. And so remember how we talked about the circumference is just the diameter of the circle times by pi. And so another way to write that is 2r is the same thing as the diameter, 2 times the radius times by pi. So what we said yesterday was that the two circles ended up having an area of this, 2 pi r squared. Pi r squared is the area of the circle, where we added on the rectangle to it, and the rectangle has an area of diameter times pi, which is 2r pi. So that's this length here times by the width, or the height of it, times h. And so what we saw was that there were common factors. We saw 2r pi as the common factor between these two terms. And so what we did is we took that 2r pi, pulled it on the outside of a parenthesis, did the reducing, and we had r plus h left over. And again, that's the formula we used yesterday. We're going to use that again here today. So we take the radius, which is 2x plus 1, and we substitute in for these two radii here. So we have 2 times by 2x plus 1. And then we go ahead and write in that pi there as well, times by the radius, 2x plus 1, multiplied, or added to, so we have this part right here, added to the 6 times by 2x plus 1. So that was what the height was. So I'll go ahead and do some work here. So this makes 4x plus 2, and then I still have the pi here. I'm going to keep that on the outside. I'll multiply that at the end, and then I'll collect like terms. There's a plus sign here, so I got to collect. Now, I'll go ahead and distribute this, so I've got 2x plus 1, so I wasn't able to quite multiply yet because I hadn't distributed this yet. And so I have 12x plus 6. So now I can go ahead and collect some like terms here. So the 2x and the 12x make 14x. 1 and 6 make 7. So 14x plus 7, and that's what I need to multiply by the 4x plus 2. So I'm going to use that FOIL method once again since I have the two binomials. And when I go ahead and do that, I still have the pi on the outside. But over here I've got now 4 times 14 is going to end up giving me 16 at the end, carry a 1, so that makes 56x squared. And then over here 4x times by, and those are the first terms, the outside terms, 4x and 7 make 28x. And then the inside terms are 2 and 14 make another 28x. And then the last terms are 2 and 7 make 14. And so I can go ahead and collect some like terms. So I still have that pi on the outside. And I've got 56. So 56x squared plus, and then 28 and 28 make another 56x plus 14. And so now I'll go ahead and multiply the pi over the terms there. So 56 pi x squared plus 56 pi x, and then plus, this number here was 14, so plus 14 pi. And these are in centimeters, so centimeters squared. That is the solution there. I'll put parentheses around that just to show that's a polynomial. They're all being combined together. So let's move on to another type of problem that we're going to end up seeing. So we'll see a couple problems, or a problem like that, and this problem is not a multiplying binomials. Here I'm multiplying a binomial by a trinomial. So we don't really have the FOIL method here. What we're using is just the distributive property twice. And so it's a little bit more, and so here we have x times by x squared. And I'm going to write down x to the third power, and then I multiply x by the negative 2x, and I get a minus 2x squared. And then I have x times by this 4, and that gives me a positive 4x. So now I've multiplied x by each of the terms. Now I'm going to move over to the 3 and multiply it by each of the terms. So 3 by x squared. Now instead of writing it here, I'm going to write it underneath the term I can collect it with. It'll be easier at the end. And so 3 times x squared makes 3x squared. 3 times negative 2 makes negative 6x. And then 3 times by 4 gives me 12. And so now I'll go ahead and add these together. So I like to line up the terms I can combine. It just makes it easier, a little more compact, easier to see as well. So I'm left with x to the third. Now I'm adding here, so opposite signs, so I really have to subtract. So it makes just a 1x squared. Here I get more negatives than positives, so here it's a negative 2x. And then I just bring down the plus 12. And it's all in descending order, so it's in the standard form. Here, same sort of thing. Difference here is that k minus 5's the binomials on the right-hand side. So I do it the same way. K times k squared makes k to the third power. K times negative 5k makes a minus 5k squared. K times 2, well, that just makes 2k. So now I've multiplied the k by each of the terms. Now let's move on to the negative 5. Multiply it by each of the terms. So I'm going to start way over here. Negative 5 times by k squared makes negative 5k squared. Negative 5 times the negative 5k makes a positive 25k. Positive because the two negative signs. And then just the negative 5 times by the 2 makes a negative 10. So I'll go ahead and add these together, and I'm left with k to the third power minus 25k squared, and then plus 27k minus 10. And that is our answer. So I'm just collecting like terms, looking at the signs in front of the terms. If they're the same sign, I add. Opposite sign, subtract. I made an error in here. Right here, I see that I multiplied 5 and 5 to get 25. I should have added those two terms. So let me fix that right now. So let's fix that and change that to a minus 10k squared. So again, the k to the third minus 10k. Adding here, so it's 27k, and then minus the 10. So let's take a look, couple other problems. We'll try here, and here are a few. So same sort of thing on this one. 2a needs to be multiplied by each of the terms. So I have it a little bit tougher here because we have the variable coefficient in front of the a term, so it makes 6a to the third power, and then 2a times a makes a positive 2a squared, and then 2a times 4 gives me 8a. And so then I move over to the next term, and so I got negative 6 by each of these terms. So I'll start here. Negative 6 times 3a squared gives me a negative 18a squared. Negative 6 by a makes a negative 6a. Negative 6 times 4 makes a negative 24. So I'm adding these together. And again, if I have the same sign, I add, opposite sign, subtract. So I have to subtract the second term here. 2 minus 18 makes negative 16a squared. Here I have to subtract again, but more positives than negatives. So I have 2a and then minus 24. And that's the solution. So look at this next one, last type here. So 3x times by 2x squared makes a 6x to the third power again. 3x times by the 2x gives me 6x. And 3x times by the negative 6 gives me negative 18x. So then I move over to the next term, and I multiply negative 4 by each of these terms. So here I have negative, and I forgot the x squared here, so let me go ahead and fix that. So 3x times 2x makes 6x squared. So I move on to the next one. Negative 4 by 2x squared makes negative 8x squared. And negative 4 by the 2x makes a minus 8x. And negative 4 by negative 6 makes a positive 24. So I get to go ahead and add this stuff up. So I'm left with 6x to the third minus 2x squared, opposite sign, so I subtracted. Same sign here, so I add, so that's going to make a 26. So minus 26x and then plus 24. And that's going to end up being the solution, or at least the product. So the last problem here talks about a medical center as a rectangular parking lot. Currently has a length of 30, width of 20. So I'll go ahead and sketch out what that looks like. Here's the rectangular parking lot. A width of 30 and a length of 20. Or, I'm sorry, a length of 30 and a width of 20. The center plans to expand, so expand means add, so this is going to tell me to add the length and the width of the parking lot by 2x. So the length by 2x and the width by 2x. So I add those together. So now what a polynomial in standard form represents the area. Area is just going to be length times by width. So I just multiply them. So 30 plus 2x multiplied by 20 by 2x, or 20 and 2x. So I can go ahead and multiply. So the first term's 30 by 20, and so here's where I get to use FOIL again, because I've got the two binomials. Here I was doing a binomial by a trinomial, so no special name for that. So my first terms are 30 and 20. That makes 600. So 3 times 2 makes 6. 2 zeros make 600. Outside terms, 30 and 2x make a 60x. And then my inside terms, so 2x and 20 make a positive 40x. And the last terms, so 2x by 2x give me 4x squared. So I can go ahead and collect my two like terms here. So I'm left with 600 plus 100x plus 4x squared. So I'm just going to rewrite this in standard form, which means just put in descending order. So the difference here is going to be 4x squared first, then the 100x, and then the 600 last. And I'll go ahead and put some units in there. So we are in meters. So we're going to say meters squared. Put some parentheses around it to show that that's the polynomial. So those are the types of problems you're going to see on tonight's assignment. Good luck.